Welcome to NPTEL lecture series, a basic course on electric and magnetic circuits. We are in module 3 on DC transients. This lecture is the last one in this module, and we will have a review on different review problems on DC transients based on RL and RC circuits. So, in the last lecture we summarize a generalized approach on finding the corresponding transient solution for RL or RC circuits. So, we say that the voltage expression can be in terms of V t equals to V infinity V naught minus V infinity e to the power minus t by tau, tau being the time constant of the circuit. Similarly, for the I t also I infinity I naught minus I infinity e to the power minus t by tau, and we generalize with whether it is voltage or current, the x t equals to x infinity x t naught plus x infinity e to the power minus t naught by tau, where t naught is the corresponding switching instant. So, we say that this V or I can be for RL or RC circuit. So, and also we saw that we can apply this approach for single storage element like C or L, whether it is charging for capacitor, discharging of the capacitor, the discharging case without any, we call it as a source free situation, with source, and then also any change in network parameter also which results in the transient situation, the same set of equations are valid. So, with this we can solve the different transient problems much easier way. We have solved few simple problems. Today in this lecture we will address few more relatively complex problem. Let us go one by one. So, this is an example, the circuit shows the different values, and we have a capacitor here 9 microfarad, and which is usually switched on at t equals to 0 to the rest of the circuit, which happens to be a resistive circuit. The question is, in the figure the 9 microfarad capacitor is connected to the circuit at t equals to 0, when the capacitor voltage what V naught equals to 17 volt, initial voltage of the capacitor was 17 volt. Find V A, V B, V C, V A at node A, V B at node B, V C at node C, I A B through this branch 2 kilo ohm, I A C, I B C for t greater than 0. Following the switching, the corresponding expression for different voltages at different nodes and the corresponding branch currents are to be found out. So, if you see the circuit, we have only one storage element, the capacitor, there is no source here. So, all the corresponding current will start flowing from the capacitor till the capacitor energy is exhausted, and this will go by the corresponding exponential way, because this is a case of source free situation. You know the situation here, but here the corresponding circuitry is having multiple number of resistance connected to the circuit. So, we will use here the nodal voltage method to address the different nodes A B node, B node and C node, and we know the corresponding injection of current is from this capacitor, and this kind of circuit we have solved in the case of DC circuits also for steady state business, and the middle branch being just like a battery here. So, we assign a current here I, and we will use the corresponding current I to solve the corresponding nodal voltage method, and then go by this corresponding solution for the current and voltage expressed from the switching event. So, let us see how we will proceed for this. So, let us the capacitor current as shown in this is I, we assign with an I, Then we will write the corresponding nodal equation for node A, node B and node C. So, for this what we say here, for node A it becomes equals to V A into 1 by 2 plus 1 by 3 plus 1 by 6, all are in kilo ohm, minus V B 1 by 2 V B minus 1 by 6 B C equals to 0. This is directly obtained in a similar way, the way we wrote the corresponding matrix equation. So, if you see here, for V A all the connections here 2 kilo ohm, 3 kilo ohm and 6 kilo ohm. So, these are the 2, 3 and 6, and for V B, because this will be V A minus V B will happen for this current. So, this is minus 1 by 2, and for V C, V A minus V C. So, therefore, 1 by 6, that becomes equals to 0. These are the 3 currents 1, 2 and 3 currents. So, that will lead the corresponding node equation for the nodal equation at A. Similarly, for the node B, it is the B. So, therefore, for B the connections are 2 kilo and 2 kilo ohm and 4 kilo ohm. So, 2 kilo ohm and 4 kilo ohm. So, 1 by 2 plus 1 by 4, and node B to node C is 4 kilo ohm. So, this is minus 1 by 4, and node B to node A is 2 kilo ohm, this is minus 1 by 2, and that equals to the corresponding injected current through this third path is nothing but the corresponding I. But because all are in kilo ohm, so therefore, this is 4 kilo ohm, 2 kilo ohm and so. So, therefore, we are multiplying this 10 to the power 3 to I here. So, that is the corresponding second equation here. The third equation for the node C is nothing but again, as I say, at node C the corresponding resistances connected are 12 kilo ohm, 6 kilo ohm and 4 kilo ohm, 12, 6 and 4. So, we got this expression for V C part. With V B it is 4 kilo ohm. So, P B it is 4 kilo ohm, and with V A it is 6 kilo ohm, and therefore, these are the 3 branches here connected to C. So, that becomes equals to 0. So, we got the corresponding third equation for node C. From these expressions we got the corresponding simplified equations 6 V A minus 3 V B minus V C equals to 0, minus 2 V A plus 3 V B minus V C equals to 4 into 10 to the power 3 I, because for this middle branch we have this I, and then third one minus 2 V A minus 3 V B plus 3 V C equals to 6 V C equals to 0. So, these are the 3 equations for this one. So, now from these 3 equations we can get the corresponding value of V A, V B and V C in terms of I. We can write the corresponding V A, V C, V B, V C in terms of I. So, these are the 3 corresponding expression of the nodal voltage expressed in terms of the unknown current I this perspective. In the next part we will go for the transient aspects. So, for t greater than 0 we like to find the corresponding currents and voltages. Now, if you see the things, then the corresponding expression for this one. So, the circuit will be nothing but it will be closed like this after t equals to 0. So, this is the corresponding for t greater than 0 circuit situation. The circuit as seen by the capacitor, from the capacitor. So, what happens that this corresponding current is injected to I, and the rest of the circuit is resistive. So, therefore, we say that the resistance R is nothing but V B voltage V B here, which is maintained by the capacitor voltage, nothing but the capacitor voltage. V B upon I, the corresponding injected current I is nothing but the corresponding equivalent resistance seen from the capacitor side. So, that becomes equals to V B divided by I, but V B we are already known that V B equals to 34 by 9 into 10 to the power 3 by I. So, if we divide this by I, then we get it to be 34 by 9 kilo ohm, that is the corresponding resistance seen from the capacitor. So, now the capacitor discharges its initial voltage V 0, that is 17 volt through this equivalent resistance of 34 by 9 kilo ohm, and this therefore, the corresponding time constant seen from the capacitor will be nothing but the corresponding R C 34 by 9 kilo ohm into the corresponding 9 microfarad, that gives us the time constant to be equals to 0.034 second. So, this was the time constant of the corresponding transient event that will happen from the capacitor by switching the capacitor to the circuit. So, for t greater than 0, the voltages and currents are nothing but V B equals to the V B will be equals to the V 0 e to the power minus t by tau, V B will be equals to V 0 e to the power t by tau. This is the source free circuit case. So, that becomes equals to V 0 is nothing but 17 volt and then e to the power minus t by tau, tau we have already obtained. So, 0.034. So, that becomes equals to 17 e to the power minus 1000 t by 34 volt. This is the corresponding expression for V b. Now, therefore, once you know the V b, you can find the corresponding I equals to minus C dV by dt. The corresponding I becomes equals to minus C dV by dt, because the corresponding I is going away from the capacitor positive terminal. Generally, we talk about when the corresponding current enters to the positive terminal of the capacitor, we take it as I equals to C dV by dt. So, this results in the corresponding expression. If you go by this, then the corresponding expression for the current becomes equals to 4.5 e 10 to the minus 3 e to the power minus 1000 t by 34 ampere. So, this is the corresponding current with that. Now, if we substitute this corresponding current in V A and V C expression, then we got this V A and V C like this. V A becomes equals to 10.5 e to the power minus 1000 t by 34 volt and V C equals to 12 e to the power minus 1000 t by 34 volt. So, we got V A, V B, V C and the corresponding I with in the expression with the expression of exponential term e to the power minus t by tau form. Now, this part is over. Now, we got V A, V B, V C and for this perspective and so. Now, to get the corresponding I A, I B, I C, the branch currents here, we need to find the V A B here. So, V A B equals to V A minus V B from these two expressions. So, we got it to be minus 6.5 e to the power minus 1000 t by 34. Then the I A B equals to V A B divided by 2000. So, because current through the resistance follow the Ohm's law. So, V A B divided by 2000 2 kilo ohm. So, that we got the corresponding expression for I A B. Similarly, V A C equals to V A minus V C. So, we got the corresponding I A C and similarly for V B C equals to V B minus V C, we got the corresponding I B C current expression 1.25 10 to the minus 3 E minus 1000 t by 34 ampere. So, we got all the values V A, V B, V C, I A B, I A B, I A C for this one. So, what from you see here that this is a source free circuit, capacitor was having 17 volt initial charge and it discharges through the different resistors in the circuit and we wrote the corresponding nodal equation approach. There is a mix of generic nodal equation and the corresponding exponential term for this case and we solve the corresponding network issue to find the corresponding expression of the voltage currents in different branches for the circuit for t greater than 0. We will go to the next example. So, this is a circuit which having a current source now and the switch will be closed at t equals to 0. So, we have an inductor here. So, that is our only the energy storing element here. In the circuit shown in the figure, the switch was open for long time, at t equals to 0 second the switch is closed. Find the value of current I t, this current I t in the downward direction at t equals to 0.15 second. At a given instant of time, we like to find the corresponding t in this case. So, as already known that we can find the corresponding current expression for this I L here for the inductor and that you can find from the generic equation as we have learned. And once you find the corresponding current expression for this, because this circuit will be closed now. So, if you see the circuit at t equals to the closed condition, then the current in this I t will be equals to the corresponding current from this side and the current going from is 2 ampere. So, you can apply KCL at this node and you can find the corresponding I t. So, then the KCL will be here equals to sum of these two current equals to 2 ampere. So, that will lead to this. So, if you can know the corresponding current for the I L, what will happen once you solve this one, then this 8 ohm becomes redundant and the current from the inductor will pass through this path. So, therefore, the corresponding this current becomes this current becomes equals to the same as this current and then we can use that approach to find the corresponding solution for this case. But again the question asked it as a particular time 0.15 second. So, we will find the corresponding current from this part to be at 0.15 second from the exponential equation and then find the corresponding I t at 0.15 second. So, let us see here. So, what we see here that the solution for this at I L 0, I L the corresponding current through this part I L will be at 0th instant will be equals to what? Because this was open condition. So, the current becomes this current goes in this path and it is being distributed here and here. So, steady state condition this is short circuited. So, therefore, the corresponding I L becomes equals to 2 ampere in parallel with 2 and 8. So, therefore, the corresponding in this branch the corresponding current will be 8 divided by corresponding 10, 8 plus 2 10. So, that gives us 8 by 5 ampere. Now, I infinity in this case in that arrangement I infinity means this will be closed. So, then the corresponding 2 ampere is shorted here and this part will also become shorted. So, all the energy contained in the 0.4 ampere 0.4 Henry inductor will be exhausted through this path through this 2 ohm resistance. So, therefore, finally, this I L will be also equals to 0 ampere. So, these are the two circuit conditions for the switching event t equals to switching at t equals to 0. So, we got the I L to be 0, I L 0 to be 8 by 5 ampere and I L infinity to be 0 ampere. And the tau the time constant from the looking at this for the second case like when this is closed. So, this will be closed means this is bypass. So, therefore, the corresponding 2 ohm is only present. So, therefore, the time constant is nothing but L by this R. So, that becomes equals to 0.4 by 2, 0.4 by 2 that gives you 0.2 second. So, this is about the corresponding time constant. Once again the time constant when you see from this inductance from this side, because at t equals to 0 this is closed. So, this is shorted. So, this 8 ohm becomes redundant. So, therefore, the corresponding resistance associated with this 4.4 Henry inductor is 2 ohm only. So, that leads to the corresponding time constant to be 0.4 by 2 equals to 0.2 second. Now, you can write the corresponding expression for I L t equals to I infinity plus I naught minus I infinity to the minus t by tau, and we substitute the corresponding 3 values 1, 2 and 3 and we get the corresponding I L t to be equals to 0 plus 8 by 5 minus 0 e to the power minus 5 t. So, that becomes equals to 8 by 5 e to the power minus 5 t. And in this one if you substitute the corresponding value of the corresponding at the time of 0.15 second. So, we can get the corresponding current I L t at 0.15 second. And now, the corresponding I as I told the corresponding I t this current will flow here also because this is shorted. So, this become redundant in this case. So, therefore, at this one the corresponding KCL we apply, then the happens to be considered I this is the I current I at 0.15 second, the plus the corresponding I L at 0.15 second, that becomes equals to the 2 ampere, that becomes equals to 2 ampere. So, this is the corresponding expression and therefrom we can find the corresponding I at 0.15 second equals to 1.244 ampere. So, this is a simple circuit at a given instant of time. What is the corresponding current flowing in a particular shorted path, that was being asked. So, we solve the equation by using the corresponding generic equation for the current for the inductor. The next example is on a circuit like this. So, we have a source and we have a capacitor. So, the capacitor was in the charging mode first. So, it was fully charged in steady state and then it is open at t equals to 0, the source is cut off from the capacitor. So, now the capacitor functions with the 500 ohm and 2 kilo ohm. The question is in the circuit shown in the figure, the switch was closed for a long time, at t equals to 0 second the switch is open. Find the value of the current, which current? This current, find the value of this current downward in the 2 kilo ohm at I equals to 0 plus at the I at 0 plus t greater than 0. So, 0 plus instant we like to find only that value, not the general expression of the I t. So, for this case as I said, because this is open. So, initially the corresponding circuit was like this is 500 ohm, this is 50 volt and then this is 2 kilo ohm and this is 500 ohm and this is the corresponding thing. So, at steady state initially this will be open circuit. So, the voltage across here the 2 kilo ohm is nothing but the voltage of this. So, this becomes equals to V c 0. So, the V c 0 will be nothing but 50 volt will be the corresponding circulating current here. So, this will be divided by this 2000 ohm plus 500. So, 2000 500, 2000 plus 500 into 500 into the corresponding 2000. So, this will be the corresponding V C 0 voltage across here 2 kilo ohm. So, that is about the V C 0. Now, in the second case this is about the initial thing. In this second case this circuit will be open. So, only this portion of the circuit will remain in the case. So, we will be using this circuit for this case and the corresponding V C infinity will be equals to 0 in that sense and so. So, from that relations we will find the corresponding I t, but we do not require the corresponding infinity perspective, we require the I 0 plus. So, for that case what we see here, as I already mentioned, V C 0 minus equals to V C 0 plus, because voltage across capacitor cannot change instantaneously. So, as I said, this will be 50 into 2000 divided by 2000 plus 500. So, that becomes equals to 40 volt. So, the V C here will be 40 volt. So, V C 0 plus will be 40 volt. So, now this switch is now open. So, therefore, we can write the corresponding expression for this one, and that becomes equals to the KVL equation for this loop if we write, then becomes equals to the other way, the corresponding current here is I t this. So, that becomes equals to 40 here, this is the source 40 volt. So, this 40 equals to I. So, the corresponding I plus into 500 to 200. So, this is the corresponding voltage. So, the current through this will be this. So, the current here what we see here will be like this, like this. So, this voltage is this plus minus 40 volt. So, that will be circulating a current of I, and that current is I into the resistance 500 plus 2000 at 2000 ohm. So, that equals to the 40 ohm. So, therefore, the corresponding I plus becomes equals to I 0 plus becomes equals to 0.016 ampere only. So, this is simple circuit, two states before the switch on and state after the switch on. The next example is having two switches here. Unlike earlier all examples, we are observing only one switching event. Now, we have two switches. See here, there are two switches here. Switch 1 S 1 is operating at t equals to 0 second, and switch S 2 is operating at t equals to 4 second. So, we see here both are being closed one after the other. So, switch 1 is closed first and then switch 2 is closed after a gap of 4 second. So, how the corresponding circuit behaves, and the question asks is about that, find the expression for the current I t greater than 0. What is I t? I t is nothing but the corresponding current through the inductor, 5 Henry inductor. So, we like to write the corresponding expression for that situation. So, now we see here this asks for solution in step by step. So, there are 3 stages, we call it 3 stages. What are those? First stage is, stage 1 is, see at t less than 0, that is initial condition. Second stage is that at t greater than 0 to the 4 second, and third stage is nothing but t greater than 4 second. So, after this, so the 4 second after 4 second, the corresponding both the switches will be closed, but between these to this second only this will be closed and this will be still open, and before the corresponding t 0 both will be open. So, that is the corresponding circuitry in terms of that. So, for those 3 stages we will analyze one by one the corresponding circuit and find the corresponding I t expression for that one. So, as already said, the solution 3 intervals t less than 0, t from 0 to 4 second and t greater than equals to 4 second case. For t less than 0, the inductor current is 0, because neither this source nor this source is available to this one. So, no current path there. This is shorted in the steady state, but then the current, there is no current flowing from this side or that side, because both switches are open. Now, so that is why this got it to be 0 ampere. So, that is first part we got. For interval 0 to 4 second, S 1 is closed, S 2 is open. So, this is closed, circuit is like this, but this is open. So, there will be no connection of this battery 10 volt battery to this circuit. So, that becomes open, isolated. So, now in this case what we say that, let us say assume that we do not know about the second switch. So, we can assume that considering S2 is open. So, we can say that I infinity equals to 4 ampere. What is I infinity? I infinity is nothing but the steady state current. So, at steady state this will be shorted. So, this will be shorted means 40 divided by 4 plus 6. So, that becomes equals to 10. So, therefore, the corresponding 40 divided by 10 will be nothing but the corresponding 4 ampere. So, we got to 4 ampere. Now, looking from this circuit from the inductor, if you see, now from the inductor the corresponding RTH will be, because this S2 is open, RTH will be 6 plus 4 is 10. So, therefore, the corresponding RTH becomes 10, and the tau, the time constant, becomes equals to L by R. L is 5. So, 5 divided by R becomes half second. Now, you can use the corresponding expression for I t equals to I naught I infinity plus I naught minus I infinity e to the minus t by tau, and substitute the corresponding I naught infinity this I infinity equals this I naught equals to 0 ampere. So, we got the corresponding expression for I t equals to 4 1 minus e to the power minus 2 t ampere. Now, this expression is valid till 4 second, because at 4 second the second switch will be closed. So, therefore, at the end of the period, that is at 4 second, the corresponding at 4 second the corresponding current I, that becomes equals to, if you substitute t equals to 4, then you got the corresponding current to be 4 ampere. So, this one till the corresponding this one. So, this will be using in the next stage. In the next stage, for t greater than 4 second, S1 is closed and S2 is closed, both are closed. So, the circuit behaves like this, S1 and S2 both are closed now. So, in this case the corresponding, if you see the corresponding the terminals A and B, how we will solve this we see here. If you see this the corresponding terminal A and B. So, at A and B you will find the equivalent VTH and RTH to analyze the corresponding rest of the circuit. So, if you see this corresponding VTH and RTH, VTH becomes equals to 20, because we say here the 20 volt, and RTH becomes 1.3. RTH becomes equals to 2 and 4 in parallel. So, that gives us the corresponding things to be considered 1.33 ohm, and VTH becomes equals to what? This 40 ohm, the 40 volt circulates a current through this. So, therefore, the corresponding 40 minus 10 will be 30 volt, 30 divided by 4 plus 2 will be 6. So, that 5 ampere current flows here. So, 40 minus this 5 into 2, you can say that gives you the corresponding voltage across here becomes equals to the corresponding drop here. So, you got the VAB open circuit voltage, that becomes equals to 20 volt, and RTH becomes equals to this. So, therefore, this I infinity. So, what we say that you got the VTH here and RTH. So, I infinity will be equals to VTH divided by this 6 plus 1.33 RTH, that you got the current to be 2.728 ampere. So, that is the corresponding I infinity through this the corresponding in the interval for t greater than 4 second. Now, we know that the initial current after the switching, that I at 4 equals to 4 ampere. In the last calculation we did this. So, therefore, from the inductor if we see and the corresponding time constant for this. So, from the inductor if we see the corresponding things. So, that becomes equal to 6 in series with this and this in parallel, 2 in 4 in parallel. So, that gives us the corresponding RTH dash, that becomes equals to 22 by 3 ohm. This is for time constant tau perspective and so. The second, so therefore, the time constant becomes L, that 5 divided by the corresponding RTH dash, that becomes equals to 15 by 22 second. So, this is after closing the switch S2. So, again we write the corresponding I t equals to I infinity and then I 4. Now, because the second one is closed at t 0 equals to 4 second. So, I 4 minus I infinity e to the power minus t minus 4 by tau. Why t minus 4? Because t minus 4 we have solved earlier also example in earlier lecture. T minus 4 is the corresponding exponential because of the switching time at this. So, this is t dash kind of thing, the corresponding exponential term start from at t minus 4 part. So, this corresponding expression becomes equals to 2.727 plus 4 minus 2.727 e to the minus 1.4667 t minus 4 ampere. This is the corresponding general expression. So, 3 stages, t less than 0, t greater than 0 to 4 and then t greater than 4. We have another example now for this circuit. So, we have a load here, the load consists of an R and L, and then the corresponding a battery is there, and battery is connected to the load through resistance R B and R S. So, the corresponding load is connected through across R S. So, that is what the corresponding mechanism, and the values are battery voltage is 100 volt and the series resistance is 2 ohm and the corresponding shunt resistance is 20 ohm and the load has a resistance of 0.8 ohm and L equals to its inductor is 3 Henry. The question is find the V t across the load, this is V t across the load for t greater than 0. The value of V b is, and all the values are mentioned in the data sheet. So, now for this case the corresponding storing element, the inductor is that. So, if we know the corresponding inductor current, then we can analyze the circuit, and the condition is that the switch here will be open at t equals to 0. So, after opening, what will happen, that the corresponding inductor will now whatever current was going will circulate through this. So, that is why the circulate through this means the corresponding voltage across the corresponding 20 ohm resistance is nothing but the voltage across the load, or we can see that the corresponding voltage across the load is nothing but I R plus L d I by dt also. So, for this we will solve the network like this. So, I L the load, the I L current through the load, that at 0 time, that is the at the switch was when closed. If we analyze the circuit at steady state, so that becomes equals to this becomes shorted. The current through this branch I L, that becomes equals to this 100 volt will be sending the corresponding current here. So, that will be divided into 2 parts. So, therefore, the corresponding 100 divided by 2 plus 20 and 0.8 in parallel, 0.8 and 20 in parallel. So, this current whatever it goes from this circuit will be now divided into 2 part here. So, this and this. So, in the 0.8 ohm it will be 20 divided by 20 plus 0.8. So, we got the corresponding current to be 34.72 ohm. So, the series parallel combination. So, this is about the when the corresponding inductor is shorted at t equals to 0. Now, the V load at 0, because our question is that what is the corresponding V t, V across this V. So, V load at that time this is shorted. So, therefore, the corresponding current here is only the voltage drop here is across the R load only. So, this current into the corresponding 0.8 is nothing but 27.8 volt. So, at initial condition before the switch was open, then the voltage across the load becomes equals to 27.8 volt. Now, I will go for the corresponding next part when the corresponding switch is open. So, once the switch is open, as already told, that the corresponding inductor will circulate current to this path, it will continue like that. So, you see here the corresponding V load, the tau becomes equals to from inductor side if you see, because this is open from the inductor side. So, from here this R 0.8 and 20 are in series. So, therefore, R t h becomes equals to 28.8 and the inductor is 3 Henry, 3 divided by 20.8. So, that gives us the corresponding time constant to be 0.1442 second. So, this corresponding I load that becomes equals to at t becomes equals to we general expression I naught into e to the power minus t by tau. So, that gives us the corresponding I naught to be 34.72 e to the power minus t by tau ampere. Straightforward, you can write the corresponding current expression for through the inductor or the load. Now, from there we will find the corresponding V t, because our target is to find the V t. V t is 27.8 for less than for t up to 0, that we have already found out from this one relation. Now, then the corresponding other one that we find out that V t equals to I, the corresponding I load into R, this is I of I load into this corresponding R, this plus L d I by dt, I load into R plus L d I by dt. So, that becomes we write like this. So, the corresponding I expressions we know. So, using the I expressions, if I write the corresponding L d I by dt, that becomes equals to a negative sign because of the e to the power minus t by term. So, and then we got the corresponding expressions to be equals to minus 694.5 e to the power minus t by 0.1442 volt. As already mentioned, however, this voltage is nothing but the voltage across the corresponding R s, and the corresponding current is same current as the load current. So, therefore, load current is known to us minus R s into the load current, that gives us also 694.5 e to the minus t by 0.1442. So, you can find this IR plus LDI by dt, or you can find also this minus IRS, both the ways you can find the corresponding voltage across the load. The next example is on to find the expression for Bt for t greater than 0. For this case, we see that the corresponding 30 volt, 4 ampere, and we have two switches, T 0 it is closed and T 0 it is open. So, one will be closed, the other will be open. So, there are two switches here. So, question is that find the expression for Bt for t greater than 0. For this case, what we do here, that because this is a capacitor, the corresponding storing element here. So, we will find that everything across the capacitor, the corresponding voltage across the capacitor V 0 and so. So, we see here first the case, because this was open and this is closed. So, now the circuit becomes like this for V c 0. So, for t greater than t less than 0 and this is open. So, that means that the corresponding 4 ampere is supplying everything. So, the 4 ampere one part goes here and one part goes here, and this will be open for the steady state business. So, the corresponding voltage across the 6 ohm will be nothing but the corresponding voltage across the capacitor. So, that means that the corresponding voltage which will be getting, because this is term as positive and this is negative. So, because this current is push current from this side. So, the voltage across here, this will be positive, this will be negative. So, we will get a negative voltage for the capacitor in that term. That becomes equals to the corresponding current through the this part, that becomes equals to 4 ampere will be divided into in terms of 6 and 3. So, the total voltage across this becomes equals to 6 and 3 gives you 2 ohm. So, 2 ohm into 4 is 8 volt. So, this is 8 volt, and the negative sign is because this current is from this side. So, this becomes positive, this becomes negative for the capacitor, but the capacitor is marked from in terms of positive and negative like this way. So, got the initial voltage to be minus 8 volt. Now, for t greater than 0, this circuit will be closed this side and this will be open. So, therefore, the circuit becomes like this 30 volt, 12 ohm and then 6 ohm and 6 ohm, and in between we are capacitor. Now, let us see from the capacitor terminal VAB. So, from there, because we like to find the corresponding time constant for that, if you see from this VAB and this we designate it as Vt. So, from VAB, from this terminal, this and this, and then the corresponding this will be sorted. So, therefore, the corresponding paths are 12 and 6 will be in parallel, and 12 and 6 in parallel. So, that will give us 4 ohm and 6 in this. So, that gives us a 10 ohm case. So, therefore, we get the corresponding equivalent to 10 ohm, and this is our VAB, and the corresponding the corresponding voltage across the corresponding the VTHP across the VAB, that becomes equals to comes out to be 10 volt in terms of that. So, so that leads to the corresponding situations to be the Thevenin equivalent across AB terminal becomes this 10 volt and this. So, V infinity equals to 10 volt. So, that is why, because this is open circuit. So, the voltage across the corresponding 6 ohm resistance will be like that, 30 divided by 12 plus 6, 18 into this 6 will be nothing but the corresponding 10 volt. So, it got to be 10 volt, 10 ohm, the Thevenin's equivalent across AB for steady state business, and then the tau becomes equals to, looking at that becomes equals to 10 ohm, as I said, 6 this becomes this. So, this 12 and 6 in parallel and plus in series with 6 ohm. So, that gives us the time constant to be 10 into 0.1 equals to 1 second. So, the Vt, the voltage the Vt turn voltage across the corresponding capacitor in time domain, that becomes equals to V infinity plus V naught minus V infinity minus t by tau. So, if substitute the value of this, we got this to be equals to Vt equals to 10 minus 18 e to the minus t volt. So, this is the corresponding expression for this one. So, here also is find two switches, one after the other, they are closed and open simultaneously. Now, I will go to another example which is one by one. So, there are 3 phases for this example. So, we have a circuit like this, 3 ampere this and 20 volt this, and we have a capacitor here, we have an inductor here, but do not get confused that we have 2 storing elements C and L, different one. So, as per our discussion, this should be either RL and RC, but here the question is confined to only this initial value of these things and only the final value. So, this is based on the corresponding principle of short circuit for inductor in steady state and open circuit for capacitor, and the capacitor voltage does not change instantaneously and inductor current does not change instantaneously. Those principles will apply and we will find the corresponding solutions for the problem what is being asked here. So, the first part is the corresponding current in inductor, voltage in capacitor, and voltage in resistor and voltage in inductor in the circuit at 0 plus. So, that we like to find, and then we talk about the at steady state the V infinity for the R, for the C and for the I L we will find. So, we will go by one by one. So, what we see here that for the 0 plus voltage and current, the circuit becomes like this. So, because the switch is here, the switch will be closed here. So, the circuit becomes here, before that was nothing but that the circuit is the capacity this will be open, because this is not connected to that, the circuit is closed after that, this is open. So, the corresponding circuit becomes this, and the corresponding in steady state business this will be open. So, therefore, we get the corresponding circuit to be like this. So, this will be I L naught, I L 0, L 0 minus, and this will be V R 0 minus, and this will be V C 0 minus. So, that means that the corresponding L is short, C is open for this case. So, therefore, I L 0 minus equals to 0 ampere. So, there is nothing, no voltage source is also working, no current source is working, and the V R 0 minus equals to 0 and V C 0 minus equals to 20 volt. So, why you got 20 volt here, the V C 0 minus is that see this path, if you see this path. So, this path is comes to this. So, it means that the negative part of the voltage source is nothing but this terminal, and this terminal, the negative of the V C is nothing but the 20 volt. So, therefore, we are getting here minus 20 volt for this V C. Now, we will go to this expression for this one. So, for t greater than 0, so we say that the V C 0 is equals to V C plus. So, therefore, the V C 0 equals to V C plus. So, that becomes equals to minus 20 volt, it will maintain. I L 0 plus equals to I L 0 minus, that equals to 0. So, that is the corresponding expression for this, that we talk about this. Now, another thing we see here, if you see this corresponding terminal here to here, then the V B voltage becomes equals to 20 volt minus 20 volt, that becomes equals to 0, and if it, because it is shorter also, this point and this point is same. So, V B becomes 0 volt. So, that is the about the V B equals to 0 volt in terms of that. So, that is the conclusion you can tell about this perspective and so. So, we got the corresponding value of all the value to be in terms of 0 plus perspective and so. Now, we see here now what we will do to find the corresponding V R 0 plus for this circuit. We see we need to use the corresponding, let us say the voltage drop across the 4 ohm resistance is V 0 plus. We designated a V 0 plus with plus and minus sign like this. V B is 0 voltage, we have already found out. So, now apply KCL at node A, KCL at node A. So, that becomes equals to 3 ampere incoming, and this is outgoing V 0 V R 0 plus by 2, and V R this V 0 plus divided by 4, because B B is 0. So, this becomes equation 1, and if we apply the corresponding middle loop to be the corresponding KVL, Kirchhoff's voltage law. So, then this becomes equals to, we can write on this V R 0 plus minus V 0 plus minus V C equals minus 20 equals to 0. So, this gives us, again we know that V C 0 plus equals to minus 20 volt. So, from this we can conclude that V R 0 plus, this becomes equals to nothing but the V 0 plus. So, this voltage is nothing but this voltage, because V B is 0 also we know. So, that is the conclusion we talk about in terms of this. Now, if in this equation, if we apply this corresponding is this expression, then we get this the 3 V R 0 plus equals to 12 volt, and therefore, we got the V R 0 plus this voltage equals to 4 volt. So, that is the corresponding V R 0 plus becomes equals to 4 volt. So, the another solution. So, from this we got all the corresponding solution for this voltage across resistance, voltage across capacitance, voltage across the inductance, and voltage across the inductance also, all values in terms of this. Now, note that the V L 0 plus equals to the V B, this voltage V B. So, that becomes equal to V C plus equals to 0 voltage, voltage across here equals to 0 voltage at 0 plus instant and so. So, this is what we say in terms of that. Now, for the corresponding infinity term, I L infinity, V C infinity and V R infinity term. So, once the switch is closed, we talk about this term. So, at infinity the circuit reaches to a steady state. So, therefore, the circuit behaves like this, it will be shorted and this will be open. So, if you see the circuit perspective, those becomes open. So, only the current source becomes active. So, one part of current goes here, one part of current goes here. So, therefore, the current to the I infinity will be equals to 3 into 2 divided by 2 plus 3. So, that gives us the corresponding the 4 plus 3 sorry 2 divided by 2 divided by 2 plus 4. So, the 4 plus 6. So, this gives us 1 ampere current, and V c infinity equals to minus 20 volt, because this is 20. So, this plus shorted means this again becomes a minus 20 volt. So, V r infinity becomes equals to V r infinity here. So, that becomes equals to the corresponding current here is, as you see here 1 ampere current here, 2 ampere current flows here. So, 2 ampere into 2 ampere is 4 volt. So, we got to be V r infinity to be 4 volt, V c infinity to be minus 20 volt, and the corresponding I L infinity to be 1 ampere in terms of this. So, that way we can see that the initial current, initial voltage, and the final current and final voltage in different branches of capacitor, inductor, resistance you can find from the basic fundamental concept of capacitor open circuit steady state, inductor short circuited steady state, capacitor voltage does not change instantaneously, inductor current does not change instantaneously in terms of that, and so. The other point I like to clarify here, that when the corresponding current flows here in the inductor like this. So, this is the initial current, let us say I 0 is flowing right like this. So, this current will only circulate at different paths. So, it will the corresponding current direction does not change in the inductor following the switching. Similarly, if you see this corresponding capacitor, if the capacitor is charged with let us say V 0 and this is plus minus. So, the capacitor when it is connected to a resistor R, the corresponding capacitor current earlier was to charge it was flowing in this direction, but now the corresponding capacitor like a battery will circulate current through this one. So, the current direction in the capacitor will change, but the corresponding voltage of the capacitor will not change, because this plus minus will be maintained throughout. Yes, that the capacitor voltage goes on decreasing till the corresponding energy is exhausted. So, these are the basic things which we should remember while solving the different circuits and so. So, with this we finish the corresponding RL and RC switching transient cases, and in this we learn that to solve the corresponding single circuit, single element storage element, either it is either it is source free or with source, and we have generic formula for that, which becomes much easier to solve the different networks transients. Thank you.